So I mentioned before that everything that we're doing is going to be basically this little table of 4 numbers, but like we've hidden it a little bit something because it makes it easier if you don't have to do this every single time for every single chair. Right. So let's do that. We're going to be able to simplify a little bit, and so we can represent not just one decision at a time, but lots of decisions all at once, which is what we're going to need to do to aggregate up to the market level. So we're going to start with something called the demand curve. So this demand curve is going to represent all these individual little decisions, right? I'm going to take millions and millions and billions of little decisions like this. I'm going to put them on a curve, and that curve is going to represent all of those decisions, specifically the outcomes of all those decisions. Do you actually decide to buy the thing or not? Stick them all together. So in this curve, what we're going to end up getting is going to give us a relationship, right? A curve is a relationship. You know, if you put a line on the board, so it's going to look like this. So we have our axes here. You're going to see these axes a lot this term. On the y-axis, we're going to put price. Which I will often abbreviate as P. On the x-axis, we're going to put quantity, which we're going to abbreviate as Q. Then I'm going to draw the demand curve. It's going to look like that. I'm going to label it demand, which I will often abbreviate as D. So what is this? What is this line that we have here? So first of all, it is a relationship between price and quantity demanded. Okay, what do I mean by that? Well, what are we doing here? Well, if I give you a price, let's say this is 10. I can follow that over. And at some point, it's going to hit that demand curve. And at what point will it hit the demand curve? Right? Well, it's going to hit the demand curve right here. So this is showing us, for a given price, how many units people want to buy. And as this price changes, let's say the price goes down to 9, you can see that the amount that people want to buy is going to go up. So whatever our quantity was before, let's say it was 12, might go up to 15. Price goes down, people want to buy more stuff. Makes sense. Okay. What's actually going on here is this. Here's the benefits. If the price of something drops, these costs are going to change, right? Because here, where's the price? It was right here. That was the price of the good. Something is cheaper. From the incentive principle, we know more people are going to want to buy it, right? Because for more people, it's going to tip the scales of this particular choice from 3 chairs to 4 chairs, or from 4 chairs to 5 chairs, or from 5 chairs to 6 chairs, or from 0 chairs to 1 chair, right? It's just going to tip more people in the side of getting a little bit more stuff because these costs are now a little bit more in favor of getting more stuff when the price drops. Price goes up, goes the other direction. People want to buy less. And that's all baked in here, right? What is this 10 actually saying? If we put 10 in, we plug in a price of 10 there, it's going to tell us for each individual person, do they want to buy or not? How much do they want to buy? You add up all their numbers. You know, if I say, hey, you do all your calculations, how many do you want to buy? You do all your calculations, how many do you want to buy? Add up all the numbers, and that's where we get this. Right? That's how many units everybody as a whole wants to buy all together. It's called the quantity demanded. How many units people want to buy at a given price. Next, it represents the marginal benefit or reservation price. So I mentioned we have marginal benefit over here, right? That's where the marginal benefit is. It's in on the benefit side. This is going to get real old. I got to figure something out about this. So when we're doing this calculation, we're comparing how much these costs go up by how much these benefits go up by, right? If it costs me $40 more to buy another chair, but it only brings me $30 of additional benefit, that's clearly not worth it, right? If it brings me $50 of additional benefit, then that's clearly worth it. So At what point is it going to matter? At what point are my scales going to be tipped when the price changes? Well, it's when the additional cost is about the same as the additional benefit, right? If a chair costs $40 more and I value a chair at, let's say, $39, I'm not going to buy it. Price goes down a little bit, oh, suddenly I'm going to buy it, right? So that benefit that I get from the chairs is going to tell me when I'm going to buy, which means that the number is right, it's in here, right? It's sort of encoded in here is how much benefit I get from the chair. Because think about it. Let's say that currently I'm not buying any chairs and there's 12 chairs being sold, right? So we pull the room, we say, hey, how many of you would want to buy a chair at 10 bucks? 12 of you say you'd buy exactly one chair. So we got 12 chairs sold. I'm not in, okay? Because I only value a chair at $9. If the price drops to $9 and I start to buy a chair, right, which makes sense because I value the chair at $9. Now that the price is only $9, I'm going to buy one. But you can also work that backwards. Hey, we observed that when the price dropped from 10 to 9, suddenly he bought a chair. He must value the chair at about $9, right? So by observing, this is all in our heads, right? You can't see into somebody's brain and know what their benefit is, but you can see what they actually buy. And so if you observe in the real world that a certain number more people buy as the price drops, well, then suddenly you know how much they value the thing at, because that's when they started to buy it. If you don't buy it at 10, but you do buy it at 9, that means that your value of the thing is somewhere between 10 and 9. So this encodes our marginal benefit. So we can say something like the 15th chair sold is sold to somebody who values that chair at a value of 9. Right? So we can go both directions here. We can say, hey, at this price, here's how many people want to buy the thing. And how much is this unit valued at? Well, we follow just back the other direction, right? Take the price, here's how many people want to buy. Here's the unit that we're selling, the 12th unit. How much is it valued at? 10. So we're encoding a lot of information in here. A lot of it's hidden in this little straight line. All right, last one's a lot more simple than the first two. It slopes down. That just says that people want to buy stuff more if it's cheap. That one's not too surprising. Oh, these are the slides. So occasionally in my slides, by the way, I'm just going to skip past stuff real quick. That usually means that I just explained it, and the slide is there for if you want to go back and look at the slides so that it's still there. I'm going to skip past this one for that exact reason. So here's just to recap what we did. Here's an example. Here's a demand curve, slopes down. At a price of 1, 20 people want to buy this candy. People want to buy candy. And also, the 20th candy sold is valued at exactly $1. Right, go each direction. All right. So the demand curve answers the question for us. How does the quantity demanded change as the price changes? Which, as you can already guess, we're going both directions here. We're going to be able to figure out how prices change by working backwards a little bit. Right? So how does the quantity demanded change as the price changes? Here, as the price dropped from 10 to 9, the quantity demanded increased from 12 to 15. On this demand curve here, we can do the same thing. But if the price went up from 1 to 3, well, then very few people would want to buy it. It would go from 20 to 5, right? We put in the 3, follow it down, 5 units going to get sold. If it dropped to 50 cents, well, if it dropped to 50 cents and sell 25 units, we can see how the quantity demanded varies with that price. Quick semantic note, by the way, something that trips up a lot of people is the difference between demand and quantity demanded. So let me just clarify that a little bit. So this line, this relationship, that's demand, okay? It is a relationship between two things. Demand is never a number. If you're doing your homework and it says, hey, what's demand here? And you put down a number, you know you've done it wrong. Demand is always a relationship between two things. Quantity demanded is a number. So to give you an example of why this might come up, let's imagine that I say, oh, hey, the Nintendo Switch is on sale. They just dropped it from $300 to $200, right? And they say, oh, people are going to want to buy that. Demand's going to be really strong for the Nintendo Switch. No, wrong. Quantity demanded for the Nintendo Switch is going to be very strong, right? Because the amount people want to buy is a number. Whereas the demand curve shows us the relationship of as price drops, what's going to happen to quantity demanded. As the price drops is already written into the demand curve. Nothing's going to change about demand when the thing goes on sale, right? The quantity demanded is going to change. So we'll come back to that later just because it's an easy thing to trip up on, but there's that. Yeah. Let me show you it with some marginal benefit a little bit more explicit. Let's say we got two people. We got you. We got somebody named David, and you're both thinking about buying some candy bars. And you thought, well, what value do I place on these candy bars? For you, you have a value of $3 on your first candy bar and $2 on your second one, right? That's your valuation. So if you don't have any candy bars, somebody offered you a candy bar worth $3, you think that's about the same. If you already have one, somebody offered you a second one, you'd say it's about $2, which is totally fine, right? If you already have a candy bar, you don't really need a second one. You don't have to value all units of that good the same. In fact, you shouldn't. David, on the other hand, doesn't like candy quite as much, puts a value of $2.50 on the first one, $1.50 on the second one. So from this information, we can map out what the demand curve would look like because we know that it represents your marginal benefit. And so we can draw it out. So let's ask ourselves at different prices, how many units are going to get sold to you and David? So let's start with a high price of 3. Let's start with a high price of $3.50. How many candy bars are going to get sold at the price of $3.50? How many are you and David going to buy? It's our quantity demanded. 0. No one's going to buy any. It's $3.50. You say $3.50. That's more than I value the candy bar at. David's going to say $3.50. That's more than I value the candy bar at. No one's going to buy any candy. So the price of $3.50, we got 0. 0 quantity demanded. That's where our demand curve will start. All right, so let's lower the price. Let's see what happens. We hypothetically say, well, what if the price was $3, right? How many candy bars would we sell? 1, yeah. You're going to buy one. You're going to buy 1 candy bar. You're going to say the second one's not worth it, but the first one is. David's going to buy nothing. So we're going to sell 1 candy bar at a price of 3. Great. All right, let's keep going. $2.50. How many units are we going to sell? 2. I think you know where this is going. How many get 2? How many units are we going to sell? $2? 3. And then finally at $1.50. There we go. So we know these 4 points are on our demand curve. We mapped it out from knowing how much you value the candy bars to give ourselves an idea of at each price, how many units are going to get sold, and at each unit, what's the value of that candy bar? What's the third candy bar that gets sold? Well, you've already bought one. David's already bought one. The next person who's going to buy one is you again, right? So when the third candy bar gets sold, it's your second candy bar. We follow the demand curve up. That says that our third unit sold is valued at 2. Your second candy bar is valued at 2, right? We can get that information back. That this information, which is secret and in our heads and unknowable, we can get back by observing what you actually buy. So we've got these points. We want to turn them into a demand curve. If you want to get fancy, you could do like a step function, which would technically describe what's going on here. We're going to be a little bit simpler in this class. I'm just going to draw a nice straight line and say that's our demand curve. So I also keep mentioning the reservation price. This is a handy idea. All this is that saying that's the worst price that you'd accept. It's your reservation price. If you ever put up an auction on eBay or something like that, it asks you for your reservation price, right? Where that says, hey, if the price is below this, I'm not even going to sell the thing. But anywhere above this, sure, yeah, I'll go for it. It's the worst price that you'd be okay with. It might not be your best deal, but you'd be okay with it. So if somebody offered you that first candy bar at $3, you'd be like, well, I only value it at $3. That's not a great deal for me. My economic surplus is basically 0. But, $3 is $3. That sounds fair. I'll do it, right? That's your reservation price. If the price was if somebody tried to sell it to you for $2.75, you say, hey, that's a better deal. I would have bought it for $3, but $2.75, that's even better. Your reservation price would still be $3 because that's the worst price you would have accepted. And this goes on both sides of the market, both on the buyer side and on the seller side. Okay. So for a buyer, you'll like low prices, so your reservation price is the highest price you'd still be willing to pay. On the seller side, you like high prices, so the reservation price is the lowest price you'd still be willing to sell for. And then the demand curve slopes down because people like cheaper stuff. Okay, let's try mapping out our own demand curve. So this is a picture of a car. I took it off the internet long enough ago that I do not remember what kind of car it is, but it looks pretty nice. So what I'd like you to think is, what value would you, what's your reservation price for this car? What's the worst, or sorry, what's the highest price at which you would say, yes, I'll buy this car? But now remember, it doesn't have to have anything to do with how much you expect this car would actually sell for in the market. Nothing to do that. It's how much would you enjoy owning this car? That's it, right? So think about a number, write down a number. All right, so I'm going to start naming prices, and I want you to say, I want you to raise your hand when we get to the first price that you'd be like, yeah, sure, I'll buy that, right? Now remember, we're not dealing with like an actual buying and selling here. You're not trying to hold out for a better price, hoping I'll go lower. I am going to go lower. I'm going to name all the prices. But just say the first one where you would say yes if that was the only way to get this car. Okay. All right. So let's start really high. Who would buy this car for $100,000? All right, zero. Totally fine, right? Okay, 100K. Yeah, zero. Okay. 50K. Nothing. Okay. 40K. 30K. All right, we got 1, 2, 3, 4. All right, 4 at $30,000. Great. Okay, you guys don't have to put your hands up again. All right, I got you. All right, next, $20,000. Who's gonna buy this car for $20,000? 1, 2, 3. All right. So we already had 4 people saying yes. We have 3 new ones. So in total, if the price were $70,000, we would sell 7 cars in total. All right, let's keep going down. How about 15,000? 1, 2, oh, lots. Okay, we got 1, 2, 3, 4, 5, 6, 7. So $15,000. We got 7 new buyers in addition to the 7 older ones. Presumably, anybody who's willing to buy at 20 would still be willing to buy at 15, right? So we get 14 sales. 10,000. 1, 2, 3, 4, 5. All right, 5,000. 5,000 for the car. 1, 2. I think that might be everybody. 2,000. 1,000. And free. You'd only take the car if it was free. Who would have to get paid to take this car? All right, so we've got this information. This is what's called a demand schedule. It's just writing out at the different prices how many units we would sell. That's it, right? So we're going to take this demand schedule, we're going to put it on our demand curve. Basically the same thing, just one's a graph, one's a table. So we're going to say the price of, we got 100K, 30K way down here, 20K, 15K, 10K, 5K, 1K. We fill the numbers, we got 0 for 100K, we have 4 for 30, 7, 14, 19, 21, and 22. And we'll go from here to here, here. We get a curve that looks a little bit like this. Now, it's not perfectly straight. That's totally fine. The only reason that I draw them perfectly straight is because it makes the math easier. In the real world, they're a little bit curvy. Nothing wrong with that. Any questions about the demand curve before we start talking about supply? Yep.
So, if you're like doing the homework or the question, it asks for the demand, is it describing the relationship?
Mm-hmm. Yeah, exactly. And when we get to it, we'll be writing those relationships as like an equation or as a line graph.